And now, from beyond our dimension, this is the JeffMara podcast. Here's Jeff.
My guest is Dr. Avi Loeb, theoretical physicist, astrophysicist, head of the Galileo Project, founding director of Harvard University's Black Hole Initiative, and he is also the director of the Institute for Theory and Computation at the Harvard-Smithsonian Center for Astrophysics and the former chair of Astronomy Department at Harvard University. His latest book is called Interstellar, which we're going to talk about and more. Avi, thank you for joining me and welcome.
Thanks for having me. In fact, the first biographical detail of my history is that I was born on a farm, and I'm curious about the world that I was born into, and that's pretty much all you need to say.
All right. Well, how does a farm boy become interested in extraterrestrials?
By chance. In fact, I was interested at a young age in the biggest questions that are in the realm of philosophy. So I wanted to become a philosopher, but I was born at the time in Israel, and after 18 years, had to serve in the military. And the option was either to become a soldier, a regular soldier, or use physics for the benefit of the country. And I chose, since it was closer to philosophy, I ended up being recruited to this prestigious program that recruits 20 to 30 young people every year. And I managed to complete my PhD in physics and mathematics at age 24. And during that program, I developed a project that was of interest to the Strategic Defense Initiative that President Reagan initiated back in the mid-1980s. In fact, there is a film now called Reagan, where this program is mentioned. And that's what brought me to the US, because we were funded at a few $1 million a year back then. And I went to Washington, D.C. In one of the visits, I came to Princeton, where Albert Einstein was a faculty several decades earlier, and they ended up offering me a position, a 5-year fellowship, under the condition that I'll switch to astrophysics. So then I ended up in astrophysics, and after 5 years, came to Harvard and was promoted to tenure within just 3 years after arrival. And at that point, I realized I'm actually married to my true love, even though it was an arranged marriage, because there are fundamental questions that we can address using the scientific method in astrophysics. The biggest questions about how everything started, and whether we are alone, for example, the subject of our discussion today. But I worked mostly on the first stars and black holes in the universe until 2017, when the first object from outside the solar system was discovered. And because it looked so weird, the name is Oumuamua, it intrigued me. I wondered whether the weirdness of this object is a result of it being technological in origin. And the minute I raised that possibility, there was a lot of pushback from the scientific community. And then I said to myself, wait a minute, why is there so much resistance to that possibility? We know there are hundreds of billions of stars in the Milky Way galaxy. Why should we be so arrogant as to think that we are alone? And unless, someone comes and sits with us for lunch, which is pretty much what Enrico Fermi said 70 years ago, where is everybody? And that's very pretentious. I said, if we observe things that look weird, we should study them more. It may not be in the form of visitors of the type that we imagined. And so I started looking into this subject, and that's what ended up as the Galileo Project that I'm leading right now. And we can talk more about the latest findings from the Galileo Project.
Well, you raise an amazing question, and that is, why is there so much pushback from the academic community?
Yeah, I think it's because there is a lot of interest from the public. The reason I'm saying that is when I mentioned this possibility of a technological origin in the first scientific paper that I wrote about Oumuamua, there was no issue. I mean, the paper was accepted for publication within a few days. But as soon as the public started showing interest and the media paid attention, jealousy in academia started playing a role. And the way it operates is that because the question of whether we are alone or not has such huge implications, it's perhaps the biggest question in science. People, I mean, the practitioners of science are just don't want one member of the community to sort of perhaps show evidence for something that they are not part of. And so they would try to, quote unquote, debunk it or argue that the evidence is not sufficient. And in this case, what happened is really interesting because there were numerous papers, more than a dozen papers written about what Oumuamua could be. And all of them talked about a rock of a type that we've never seen before, like a hydrogen iceberg. We've never seen such a thing. We don't know if nature makes it. Nevertheless, it appealed to the community just because here is a natural path of making the weird properties of Oumuamua. And by the way, it explains only one weird property, not others. And I showed that it can't be a hydrogen iceberg because it would have evaporated before it would have arrived to the solar system. And the authors agreed with me. So then another suggestion, a nitrogen iceberg. Again, there was an issue with the mass budget, not enough nitrogen, solid nitrogen in the universe. Then maybe a dust bunny. And all kinds of suggestions, one after the other. Every few months, a different team would suggest something. But it's obvious that if all of these papers are being written, first of all, there is a problem. So you can't argue, no, there is no issue. It must be natural, like the community was claiming. You can't say that if every few months a different team suggests something completely different, because if it was obviously natural, we would all know what it is. But you can't say it must be natural if you don't know what this natural object is, and you have to come with something that we've never seen before. And the last one, like a dust bunny, that's a collection of dust particles 100 times less dense than air. So extremely fluffy, being pushed by reflecting sunlight. All of these suggestions are of things that we've never seen before. And for the community to be so confident and argue that it cannot be artificial in origin, which is what I claim, is just inappropriate. It's not honest. And actually, a few years later, the same telescope in Hawaii discovered another object that was pushed by reflecting sunlight. It was given the name 2020 SO, turned out to be a rocket booster that had very thin walls and was pushed by reflecting sunlight. And that proves my point that a technological object, in this case that we produced, shows the same qualitative features of Oumuamua, which was pushed away from the sun by some mysterious force without showing any sign of evaporation like a comet does. And moreover, was most likely flat in its shape and with at least 10 times more in length than in projected width on the sky. So these unusual properties could potentially indicate technological origin. Obviously, we didn't have enough data because everyone thought it's a rock. But all I was saying is, let's be curious. Why should we assume that it must be natural? If something is weird, let's look for more objects of the same type, or try to find another object. And that's all I was claiming, but it got a lot of heat. And to me, it illustrated how there is a lot of room for improvement within the scientific community, how people are not open-minded on a subject that the public cares so much about. And the public pays taxes that are funding science, so we should attend to that possibility rather than dismiss it.
I believe from what people are saying, it's the size of a football field or a soccer field.
Yes, 100 meters.
Okay, to me, that's pretty small for something out in the vastness of space. How do you even find that in space in the first place?
Very simply, this size is dictated by the amount of sunlight that was reflected from the object being at the threshold of being detectable by existing telescopes. So the idea is that objects that are much smaller, there may be a lot of them. In fact, there could be 1 million of them for every Oumuamua-size object. But they just don't reflect enough sunlight for our telescopes to notice them. And so bigger objects, of course, would reflect more sunlight, but they are rarer. And an object like Oumuamua is only discovered once every few years, maybe every decade. So bigger objects, we just have to be patient, for monitor the sky for a century, and then we'll find bigger objects. Now, the thing is that only over the past decade, we monitored the sky with telescopes powerful enough to see an object of this size. But we can't see objects much smaller than that unless they come very close to Earth. Or if they collide with Earth, then they produce a fireball as a result of their friction on air. And that is called a meteor. So meteors can be seen down to much smaller sizes. And in fact, the first meteor from outside the solar system was discovered before Oumuamua in 2014. And I mean, it was detected, but not really discovered. Nobody noticed until in 2019, because I was intrigued by Oumuamua. I asked my student to look at a catalog of meteors, and there we discovered this meteor that was identified by US government satellites. And it exploded over the Pacific Ocean in 2014 and was roughly 0.5 meter in size, much smaller than Oumuamua by a factor of 200 or so. And the fireball that released 1% of the Hiroshima atomic bomb energy was spotted by sensors on US government satellites. And, at first, talking about pushback, when we submitted a paper about this meteor, my colleagues argued, we don't believe the US government. They make mistakes. This is not a real meteor from an interstellar origin. And so I reached out through the White House to the US Space Command, because I chaired the board on physics and astronomy of the National Academies at the time. And eventually, 3 years later, the US Space Command issued a letter to NASA in which they confirmed at the 99.999% confidence that this object indeed came from outside the solar system. And at that point, I decided to lead an expedition to the Pacific Ocean from the Galileo Project to search for the materials from the wreckage of this meteor, because I was wondering whether it's natural or artificial in origin, because the object was moving faster than 95% of the stars in the vicinity of the sun. And moreover, it was very tough. It only disintegrated in the lower atmosphere of the Earth, 20 kilometers above the Pacific Ocean, where the density of air is up to 1,000 times more than most meteors witness before they disintegrate. So I said, well, maybe it's a Voyager-like meteor. Let's go and check. And, not only that we invested a huge amount of work going there, collecting materials, analyzing them, and reporting about the analysis in a paper that was just published a few weeks ago. That was a huge amount of work that we had to do. But people who were just sitting on their chair, not doing anything, were trying to argue that, first of all, they don't believe the US government. Second of all, we went to the wrong place. Third of all, we found coal ash. All kinds of statements that are just meant to muddy the waters. And many journalists would pay attention to these people and say, oh, there is a controversy. But if you look at it, they didn't have access to the materials. They just dismissed the data coming from government. It's really, the worst you can imagine in toxicity, where you can easily say, I don't believe this, I don't believe that, and close the argument. But that's not the way science is done. Science is based on evidence. It's supposed to be, if we retrieve materials and we analyze them, you should wait until we publish a paper, and then if you have criticism, voice it out.
I don't know if the Webb telescope was in service at the time, but if it was, couldn't we have just pointed that or the Hubble telescope at Oumuamua and take a better look?
Yeah, so that is an excellent question, because indeed we did not have the Webb telescope. We had the Hubble Space Telescope, but The idea of using a space telescope is that it's away from Earth. So just like we have two eyes that allow us to gauge the distance to a predator, that's the reason we have two eyes. If you have a telescope on Earth and a space telescope, it allows you to look at the object from different directions and assess the distance as the object moves. And the Webb telescope is 1 million miles away from Earth, and the Hubble Space Telescope was 1,000 times closer to Earth. So with the Hubble Space Telescope that was available at the time of Oumuamua, it was possible to say that there is some force acting on the object, but it was not possible to say exactly how the force declines with distance from the sun. It was consistent with inverse square dependence, that is what you expect from radiation pressure pushing the object, but it wasn't conclusive whether it's 1 over distance squared or maybe 1 over distance or 1 over distance cubed. And that's because the Hubble Space Telescope was too close to Earth. However, nowadays, with the Webb telescope, if we were to look at a similar object like Oumuamua, then we should be able to pinpoint very precisely the location, the three-dimensional location of the object as it moves through the solar system. And that would allow us to figure out if there is propulsion, or if there is an extra force, how does it change with location, distance from the sun? And the hope is this will be actually quite effective as soon as the Rubin Observatory in Chile will start operations next year, because it will survey the southern sky every 4 days with a camera of 3.2 gigapixels, 1,000 times more pixels than you have in your cell phone. And so it has a good chance of finding objects like Oumuamua every few months. And then we can use the Webb telescope starting next year. In fact, I just submitted a proposal to the Webb telescope less than a week ago, suggesting to do just that. And that would be fantastic if we get that data. So you see, my ambition, my goal is to get as much data as possible about anomalous objects that look weird. Those that think that they know the answer in advance, those that think that everything in the sky must be rocks, they are not excited about it. They don't want to see more data. They would argue that anything unusual is just explained by natural explanations. As one of them told me, Oumuamua was so weird, I wish it never existed. And so for them, it's a problem when there is an anomaly, because they want to explain everything by things that they already know. And if you get more data, well, on the one hand, it may explain it the way they want it, but there is also the risk for them that what they are arguing for is incorrect. For me, since it's an exploration, it's a learning experience, I would like to get as much data as possible. I would like to be flooded with data so that if we see that it's not natural, it would be obvious.
I wanted to ask you this. Things on Earth, ancient structures, weather over time with erosion and degrade. But let's say if a craft was floating in space for billions of years, will there be any changes to it that will break it down like what would happen on the planet?
Or even more, because what happens in space is there are energetic cosmic rays. These are particles that move near the speed of light, and they are everywhere. And so over time, they erode. In fact, that's why humans cannot survive more than a few years in space, because most of the cells in the human body, in the human brain, would be damaged after a few years if you are not protected. What protects us on Earth is the magnetic field of the Earth that blocks those particles, and also the atmosphere, where these particles are sort of, we are shielded from them. We are living in a womb. We are protected by the Earth environment. And so far, the space station was within that womb. It was not as dangerous as venturing into interstellar space. Now, even when you go, let's say, to Mars, the amount of cosmic rays is less than you find in interstellar space outside the solar system, because there is a heliosphere. That's a region where the wind coming from the sun is stopped by the surrounding medium, and there are strong magnetic fields there carried from the sun that block most of the cosmic rays. So that we have double protection within the solar system, one around Earth and the second in the heliosphere, about 100 times the Earth-Sun separation. But when you venture to interstellar space, that's where you're fully exposed, and that could degrade any surface. And we see that potentially also in objects that come from the outer solar system, from the Oort cloud beyond the heliosphere. They're often red and damaged by cosmic rays. But in addition, there would be dust particles and gas particles that keep colliding with those objects that will degrade them further. Of course, if the object is very massive, this will just affect the surface layer. So if you have a spacecraft that is big enough, you can protect it in principle, but the protection will need to be bigger and bigger in width as the speed of the spacecraft increases. So if you imagine a craft moving at the speed of light, it's really difficult to protect it over billions of years. That's one of the major issues of traveling at very high speeds across interstellar space.
Well, I'm glad you brought that up because many people believe that we've already been visited by ETs. And I want to know, how can they travel that distance? Because traveling the speed of light, if it's even possible, is not fast enough.
Well, in fact, within the Milky Way galaxy, there is no problem, because even traveling from one side of the Milky Way galaxy disk, the disk of stars, to the other side, just takes a couple of billion years. I wrote a paper a few months ago with my student about where will Voyager be in a billion years? And the answer is that it will be on the other side of the Milky Way galaxy relative to the sun. And so you can traverse the Milky Way galaxy with chemical rockets that we built, like Voyager, Pioneer, New Horizons, in a billion years. And that means that they could have reached us, those other civilizations, by now, because most of the stars formed billions of years before the sun. If you ask when were most of the stars in the Milky Way galaxy formed, there was a peak in the star formation history about 10 billion years ago. The age of the sun is 4.6 billion years. So there was plenty of time difference between the oldest stars, most of the stars in the Milky Way, and the sun. The sun is a late bloomer. And that means that if there was a civilization next to another star like the sun, and there were hundreds of billions of them in the Milky Way galaxy, even if one of them was more advanced than we are, I mean, they could have reached us by now. Their sun probably died by now. I mean, there could have been a lot of tragedies of civilizations losing their star. And unless they went into interstellar space, they did not survive. I mean, I call it Noah's spaceship. You need to build, just like Noah in the biblical story, built a ship that would preserve life from the great flood. In the distant future, we will need to do the same in order to save what we cherish here on Earth. And I call that in my book, Interstellar, I call it the Noah's spaceship.
Well, do you think it's possible that wormholes exist and we could travel through those?
Yeah, so the problem with wormholes is that they, if you just look at the early solutions in Einstein's theory of gravity, they would snap very quickly without allowing even light to cross them. And then one way to stabilize them is to use some exotic matter that has negative mass. The problem is that if you were to build such a wormhole, you could build a time machine, because going through the wormhole will be much quicker than going outside the wormhole. And in principle, you can go back in time if you were to go through the wormhole and visit a younger version of yourself. And that is a problem, because it would mean that if you can go back in time, why didn't anyone kill Hitler? Or why, why haven't we seen people from our future? Or, there is no evidence. There is also a logical inconsistency, because you could go back in time and kill your ancestors, and that would mean that you don't exist. But how is that possible? That is not a logical possibility. So that led Stephen Hawking to suggest a law that forbids time machines, that says it's called the chronology conjecture, that basically historians everywhere would always agree about the order of events. You can never go back in time. There was also an interesting twist on the wormhole idea, and that is that if you introduce quantum mechanics to the discussion, it turns out that they might be self-destructive, because quantum fluctuations would be amplified when they go through the wormhole to make them completely unstable and kill and destroy them. And since we don't have a theory of quantum gravity that unifies quantum mechanics and gravity that is predictive, we can't really reach firm conclusions. But there were suggestions by Kip Thorne and Stephen Hawking demonstrating that perhaps these wormholes are unstable. So my guess, in answer to your question, is that it's not possible probably to move faster than light through a wormhole, for the same reason that it's not possible to go back in time. We haven't seen a time machine as of yet. If we ever see a time machine, then that would allow for the possibility of a wormhole.
Do you think we'll ever develop the technology to create anti-gravity?
That is possible, because anti-gravity is a real physical effect. According to Einstein's theory of gravity, the vacuum produces a repulsive gravitational force. So this is called the cosmological constant that Einstein introduced when he came up with his general theory of relativity back in 1915, November. He wrote down the equations, and then he believed that the universe is static, that it doesn't expand. He thought that is a very appealing possibility, because if it were to expand, it means that it started at some point in time where the density of matter was infinite. And he thought that is not philosophically appealing, to have a beginning in time. So he said, well, maybe the universe is not expanding. At the time, it was a possibility. And to do that, you need to introduce anti-gravity. So he introduced a constant to his equations that balances, this is the cosmological constant, that balances the attractive gravitational force between matter particles. And he thought, oh, maybe you have this perfect balance between the anti-gravity of the vacuum, or the cosmological constant, and the attractive gravity of matter. And if the two balance each other, the universe will not expand, it will stay still. But then shortly afterwards, he and other people realized that this is not a stable solution. If a butterfly moves its wings, there would be a density perturbation. And if the density is slightly above this delicate balance, everything will collapse. And if the density is slightly lower, the universe will expand and get diluted. So it's not stable. And indeed, about a decade later, it was realized that the universe is expanding. So Einstein was wrong about assuming that it was static. But the cosmological constant still exists. It was discovered by two young people that were in my department shortly after I arrived to Harvard. And one of them told me that he discovered it as a result of attending my class, where I said that you can infer cosmological parameters just from measuring distances. And he was a student in my class. And then they used the supernovae as a way of, these are exploding stars, as light bulbs that allow to gauge the distances in the universe, if you know how much light they emit. So anyway, the discovery was that the universe is not only expanding, but its expansion is accelerating in time, which is just like the effect of negative gravity, of repulsive gravity. as the universe gets diluted, if there is vacuum energy that doesn't get diluted, it eventually dominates because matter gets diluted. And eventually the repulsive force of the vacuum wins over that attractive force of matter. And you end up with an accelerated expansion. And the Nobel Prize was given for this discovery. So we actually measured on the scale of the universe, we measured anti-gravity or negative gravity, repulsive gravity. Now, the question is, what is the origin? What is the nature of this vacuum energy density or mass density, which we call dark energy? Because if we understood it, the next question is, can we excavate it? Can you take some of this energy and put it in a vessel? And if you would be able to do that, that object that you created, in principle, could have had repulsive gravity or anti-gravity. I should comment in relation to what we discussed before, that would also potentially make an object with a negative mass, if you were to do that. And as we said before, if you have an object with a negative mass, you can make a wormhole, or you can also create a time machine. And so if you don't believe in time machines, and therefore not in wormholes, there is no way for us to concentrate the dark energy into a vessel such that you would end up with an object that has negative mass or repulsive gravity. All of these things are connected to each other.
Is it possible that that object exists somewhere naturally occurring, either in space or on another planet?
Yeah, well, it's possible that a civilization far more advanced than we are, that knows how to unify quantum mechanics and gravity, found a trick to create such an object, to somehow excavate the dark energy. All I'm saying is, if they manage to do that, then if they have an object with a negative mass, they can also have a time machine, and they can also potentially create a wormhole. So, everything is possible because we can't be assertive about the fact that it's not possible, because we don't have a quantum theory of gravity that is predictive. Once we will have that, we would be able to say what is possible and what is not in the context of quantum gravity. But as of now, what I just mentioned is possible.
Do you know who Haim Eshed is?
Yes.
All right. He's a former Israeli space security chair that said that ETs are waiting for humans to understand what space and spaceships are. So I want to know how you define what space is, and can you speculate on what the ETs are waiting for us to know what space really is?
Yeah, so my approach is not to assume anything, because our imagination is limited by our experience on Earth. As we just discussed, there could be things far beyond what we imagine, okay? So instead of assuming something, which is the mistake made also by my colleagues in academia, they assume they know, things in advance. And that the problem with that is then you are losing your curiosity and you're not looking for evidence that may prove you wrong. Okay, so I prefer to be agnostic and be open-minded. And so how can we make progress? The way to make progress is look for things that are not familiar by surveying the sky. So when the Director of National Intelligence came up with 3 reports to the US Congress saying that military people notice things that we don't identify, we cannot figure out, I said, that's intriguing. So the Galileo Project built an observatory that is monitoring the sky 24/7, and we're about to have a scientific paper summarizing our early findings, the data that we obtained from that observatory. We monitored 500,000 objects so far, and we are building 2 additional observatories to look at the sky. And there will be the Rubin Observatory, as I mentioned, that could potentially see objects that are unidentified and not familiar. And, that's the way to make progress. You are not assuming what these objects are, but you're just asking, are there any things that we don't understand, that do not resemble birds, leaves, clouds, airplanes, drones, satellites, things that we know exist? And the way to find them is either by them having an image that looks unusual, or if they move in very unusual ways, in the sky.
You write about preparing for ET contact in your new book, Interstellar. Can you share with us some of the ways that we should do that?
I think, first of all, we should be curious, because it's arrogant to say we don't have a neighbor because we don't have extraordinary evidence for that. Obviously, if you're not searching, if you're not seeking the evidence, you will not find anything. The question of where is everybody is a question that any lonely person asks. And what you tell a lonely person, if you want to find a partner, you better do something. Don't assume that you're so attractive that everyone will come to you. Okay? So you should, in the context of searching for ETs, we should search the sky. As I said, there could be 1 million objects like this meteor that I mentioned right now within the orbit of the Earth around the sun. We calculate about 1 million of them that are 0.5 meter in size. And we can't see them with existing telescopes. So we can potentially build new telescopes that will search for them. We can look for meteors that appear to be unusual, move very fast, or are particularly tough. We can search for objects that pass near Earth at very high speed. All of the objects that in the past were monitored, they move at 1 part in 10,000 of the speed of light, which is the typical speed of the Earth around the sun or other asteroids within the solar system. But we don't have currently the software that allows astronomers, for example, to search for much faster objects, because they would appear as one image, in one image of the telescope, and then disappear, and astronomers would just ignore them. So it's really important to define a research agenda that would allow us to discover things we don't expect. And another example is artificial lights. So the objects we usually see in the sky, close to Earth, reflect sunlight. And if an object emits its own light, like an artificial light, the way it dims as it goes away far from us is different from an object reflecting sunlight, because it's just like in the case of having a lamppost, and you look at the reflection of light from the lamppost at night from an object, you can easily tell as the object recedes from the lamppost whether it emits its own light or it's just reflecting light from the lamppost. And the way to do it is by seeing that if it's just reflecting light from the lamppost, it fades away much more rapidly with distance away from us. So I actually asked an astronomer that studies objects far away in the Kuiper belt whether he ever checked whether they emit their own light or just reflect sunlight. And he said, why should I check? They obviously just reflect sunlight. And so many times, the reason you don't hear about discoveries is because the scientists are assuming the answer. And that is, the first hurdle to overcome, because this way we will never discover anything new. The second is funding. We invested billions of dollars in the search for dark matter. 85% of the matter in the universe is of a type that we've never seen. And we haven't found it. So I say, why not invest similar funds to the search for objects from other civilizations near Earth? This is a question that is even of more interest to the public. It will have greater impact on the future of humanity. It could inspire us to do better if we find a smarter kid on our cosmic block. And nevertheless, the amount of money allocated for such a search within the Galileo Project is less than 1% of what was allocated to the search for dark matter. So obviously, without searching, you will not have extraordinary evidence, which is the situation we're in. And so we need to change this narrative, and we need to invest more funds in the search. And let's say if over several decades, we invested billions of dollars and I know exactly what can be done with it, we don't find anything, we would be actually at the same situation as dark matter searchers are right now.
Do you believe that all or nearly all of the ETs that are potentially out there that could reach us would be benevolent? Or do you agree with Stephen Hawking that thinks that we shouldn't be advertising ourselves to the galaxy.
I'm not worried about predators for a variety of reasons. I don't think that we are very significant in the cosmic scheme of things. We just arrived late to the party. And, we only had a century of science and technology. And so there were other participants in that party that existed before us, billions of years before us. We're not at the center of the party. And we keep thinking that if they come here, it's because of us. No, they didn't know that we are intelligent, that we are technological when they started the journey. Humans existed for just a few million years, one part in 10,000 of the age of the universe on Earth. And, we also became technological only about a century ago. That's when we distinguished ourselves from nature. And if they started the journey millions or billions of years ago, they didn't know about us. So I don't think that we have something to worry about. I think it's more likely that we have something to gain from encountering them, because we will learn about new technologies. We will get inspired to explore space the way they do. We would just realize what it means to be intelligent. It doesn't mean to fight over territories on a piece of rock that we were born on, this rock that we call our home, Earth, which is just leftover, from the formation process of the sun. It's really not intelligent to fight over territories and have wars and that consume a huge amount of resources as we have right now. The military budgets worldwide are $2.4 trillion. A third of that is the US expenditure. Just imagine how much science we can do if we were to invest that in space exploration. And not only we would find clear evidence potentially for our neighbors, but we would also develop space technologies that allow us to go places that mitigate the risks from catastrophes that are existential threats to our future.
Well, you mentioned a reason why we need to become interstellar earlier, but is another reason because we might just annihilate ourselves?
Yeah, either we will do it as we, we are going in that direction now, or it will be a catastrophe triggered by artificial intelligence, AI, or it will be, so other than a global war, it could be a change of the climate. It could be a big object colliding with Earth that we are too late to deflect. It could be the sun erupting in some very unusual fashion. And, we know that about 150 years ago, there was a huge flare from the sun that impacted the Earth. And if it happened, right, that is the Carrington event. And if it were to happen now, it would cause losses in the technological infrastructure that we have, the satellites, communication, and so forth, at the level of trillions of dollars. And we just got used to the notion that nothing will happen to us from space. I don't think that's a good notion. One way or another, we need to venture to space, and instead of fighting on limited resources on Earth, just explore the vast amount of real estate that is available for us out there. That's the only way to preserve what we care about. And, Elon Musk talks about going to Mars, but I don't think that's ambitious enough, because, it's just like imagine us being in the jungle during the days that humans were in the jungle. You are sitting on one tree, and Elon Musk that is sitting on a branch of this tree saying, oh, look, out there is another tree that we can jump to. Maybe we can find more bananas there, or maybe we should do that. And I say, well, okay, we will go to another tree, but it's just another tree produced by nature, okay? So the planets, Earth and Mars, are just two rocks that were left over from the formation of the sun, and they happen to be at particular distances from the sun. They are not necessarily the best places for us. It makes much more sense for us to build a space platform that we can design to fit our needs. And that is equivalent to going from the jungle to a city, which is what we have done. We are currently occupying cities where you don't need to fight for bananas. You can just buy them in the grocery store, okay? And the quality of life is so much better in a city than it was in a jungle. People live much longer, medicine is available, and so forth. So going from a city on Earth to space is less of a leap than going from a jungle to a city. That's what I'm arguing. And I'm saying we should be ready to venture to space and build our own platform instead of going to another rock just because it's out there. Why should we be happy with what nature gave us? Let's just build a space platform that fits our needs.
What about building one of those on the moon? It's at least a lot closer.
Well, we
to
can
us.
start from the moon, obviously, just to learn how well we can do that. And then, from there, we can use what we learned and build a space platform. Yeah, so there would be steps as we make progress. But unfortunately, the interest in the moon, the interest in space is driven by national pride, national security. That's the race between China and the US. It's not driven by curiosity or saving humanity as a whole. It's more, extending the competitions we have on planet Earth to the moon. So it's a competition between China and the US for national security purposes, for prestige. It's not really an international effort by all humans on Earth to bring a better future, which is what I'm advocating for. So my point is, actually, instead of listening or being guided by our politicians, we should be guided by by interstellar visitors. I think we need a shock therapy here to bring us to a better state of mind.
All right, I'm going to take you into a different profession. I don't know how you're going to respond to this, but what do you think about structures like the pyramids? I mean, do you really think that they were built with bronze tools and put together when supposedly we can't figure out how to recreate them now?
Well, it's possible that these early civilizations were far more sophisticated than we imagined them to be. It's also possible that they benefited from some intervention from a visitor. We just don't have any documentation that will tell us what really happened. And by the way, the documented human history is only 5,000 years old. That's nothing. That's one part in about a million of the age of Earth. So it's really the very latest. And just think about the fact that humans existed for millions of years before that. So a lot has happened. We don't know if there was a visitor over the past few million years. We don't know whether there was a visitor over the past few billion years. Maybe life was seeded by a visit in the past. These are open questions, and without documentation, without having instruments monitoring the Earth the way we have now, we would never figure out what really happened and what our true origins are, both culturally, how advanced were early civilizations, and also what triggered human intelligence, here on Earth. We would never figure it out just because there is not enough documentation. But if we do find a visitor in our future, we can then ask whether it visited before. It's just like the Messiah. There is a claim that the Messiah, will arrive in the future, and then we can ask the Messiah whether they visited us earlier, because the main difference between Judaism and Christianity is the claim that Messiah already visited us. Whereas, in Judaism, the claim is that the Messiah will arrive in the future, but never visited us as of now. And we can settle that just by waiting for the Messiah to arrive and asking, did you visit us before? So in the same way, there is no reason to argue about past visits. We just need to find a visitor and ask whether that's the first visit.
Well, if people want to find out more about your new book, Interstellar, should they go to your website or to Amazon?
They can find it in Amazon or any other bookstore. There are also essays that I write every day or two on medium.com. And there will be a Netflix documentary coming out at the end of 2025, actually, about my research, especially the trip to the Pacific Ocean. There are a few other exciting developments that will happen in the coming year, but I cannot mention them at this time. There will be a special announcement about them within a few months.
Do you think it's possible that there is a species of ETs? I don't like to really use the word ETs when I'm talking about this, but underwater beings that are here with us and remain concealed.
It's quite possible. There is no special reason to prefer air over water. I mean, if they are near Earth, they could easily maneuver into the ocean as well, where it's more difficult for us to find them. Water is also useful if one is using electrolysis, basically driving electric currents through water, maybe powered by sunlight, to separate the water molecules into hydrogen and oxygen, because hydrogen, molecular oxygen are very good fuels. And if you want to fuel whatever instrument you're using by a very efficient fuel, you might look for water and break it up. That both the oxygen and the hydrogen are excellent fuels.
Avi, before we wrap it up, can you leave us with one last positive message?
Yeah, I think if we invest relevant funds for the search, we are likely to find things that we have never expected. And I say that because there are hundreds of billions of stars like the sun in the Milky Way galaxy alone. And it's very likely that there were things like us or even more advanced than we are billions of years ago. And rather than ignore the sky, we should search for our partners, because just like in our private life, they could give a new meaning to our existence. And my hope is that this will happen in my lifetime.
Avi, thank you for your message, and thank you for being my guest.
Thanks for having me. It was a great pleasure, Jeff.
The pleasure was all mine. Thanks for watching the JeffMara podcast. I really appreciate you. Another way to show support is through YouTube memberships. And if you do, there are loyalty badges and other perks depending on your level of membership. All you need to do is click the join button underneath the video to find out more. Thank you for your support.